In this video, I'm going to talk about what is area elevation curve and how to prepare area elevation curve. In this screen, you are seeing a dam of a polder, and it is polder 71. And to make a dam, you need to have a XYZ file, and which is derived from the topographic survey. After surveying, you will get the XYZ file, and then you can prepare a DEM file, which is a digital elevation model in ArcGIS. Using ArcGIS tool, you can prepare a dam map. So it's a DEM of this polder, as you see in the screen in the left side. And in the right side, in this plot, you are seeing an area elevation curve. So what does area elevation curve means, and what's the significance of area elevation curve, and why do you use use area elevation curve? By area elevation curve, we can easily check the topography. We can have idea about the topography of any particular area. For any kind of study, we need to have an idea about the topography or land level of a area. So in this curve, we are seeing in the y-axis is a cumulative area, and the x-axis is elevation, and the secondary y-axis the area percentage. This area percentage is cumulative area percentage. Later on, I will show you how to prepare this area elevation curve. At first, let's understand this curve. So here 83% area of Qutubdia Island falls under 2.5 meter PWD. What does it mean? 83% area. That means if the total area is 100 acre, 83 acre of this area falls under 2.5 meter PWD. We can check from the area elevation curve. Let's say 83% here. It is 2.5. So 2.5, 83%. That means 83% area falls under 2.5. That means the land level of 83% of this polder is below 2.5 meter PWD. PWD is the datum of datum which is popularly used in Bangladesh. So another thing, you can also check the corresponding area. Let's say 2.5. Here area is 40 square kilometer. The total area is about 50 square kilometer. So 40 square kilometer is under 2.5 meter PWD, and so you can check any elevation like 6 meter PWD. 6 meter PWD is let's say 4 meter PWD. There is no value more than 4 meter PWD in whole area, the land level you see here. After this, it is almost straight line. That means all the area falls under 4 meter PWD. There is no area which land level is more than 4 meter PWD. 100%. Here you see the 100% area is 4 meter PWD. So this is the significance of a area elevation curve, which gives us the idea about the land level of any particular area which we are studying, or any kind of research study or feasibility study. So from ArcGIS, in the lower portion you are seeing some data or another frequency distribution. Actually this frequency distribution you can get automatically from your ArcGIS tool if you create a raster file from XYZ file. I have already shown in my previous video how to prepare a raster file from XYZ file, so you can check that video. So here you can see the frequency distribution, how the area elevation, how the elevation, how the land level of this area is. You see here, the minimum is minus 0.63 and the maximum is 9.52 meter PWD, and the total the mean is 2.3, standard deviation is 0.85. See, there are also 7.5 to 8.9, which is very minor. So tiny areas are falls in this range. See, my elevation is 8, up to 8 there. 4 to 8, 100%. So that's how we can understand the land level of a area by this area elevation curve. Now let's check how to prepare a area elevation curve. At first, you have to reclassify your raster data. I have shown you how to reclassify a raster data. In a raster data or in a DAM, you will not get a attribute table. So to get a attribute table, or you can make classes, you can input your class manually in the reclassify tool in the ArcGIS, and then you will get a attribute table corresponding to that reclassified file. That is also a raster file. So from that attribute table, you will get the values like this, as you see in the Excel file. I have just copied from that attribute table and paste on the Excel sheet. So in elevation, 2 value 1, 2, 3. I have given 10 classes on that reclassified raster file. See here, in elevation 2, there are count 34 and 2.5 to 2876. This count is actually the cell number. How many cells belongs to this 2.5 elevation? So if your cell size is 25 by 25 meter, then you have to multiply your count number by 25 into 25, then you will get the total area corresponding to this elevation. So you can see the formula here. So then you can, this is square meter, and I have just converted this into square kilometer. Then this is a cumulative area. So how will you do it? You will just this is E2, actually this one, and this one is E2 plus E3, and this one is F3 plus E4, and this one plus this one. So you will continue this calculation up to the end, and this is our percentage of area. So the total number of total area is a summation of this area column, this one, and now you can add the formula like this, as you see in the screen, and you can continue the calculation up to the end. So after doing these calculations, you can prepare this plot easily. In primary axis, you will give the cumulative area, which is square kilometer. This is cumulative area, and the x-axis you will provide the elevation, and in the secondary axis you will provide the cumulative percentage. this one. So the percentage value will be shown in the secondary axis, and the cumulative area will be shown in the primary axis, and the elevation in the x-axis. So this is your area elevation curve. So this area elevation curve will not match with that area elevation curve that I've shown here. This is another data. All data has been altered because this is not the original data, so don't use this in your professional works. You can just take the idea of area elevation curve for learning purpose. And thank you guys. Thanks for watching.